Guys, today we're going to review the rest of Unit 8 in preparation for the test that we are going to have tomorrow. So for this part of Unit 8, here's our list of all our trigonometric identities. We are only doing from this line downward. So starting with sum of angles and everything after that. So you are going to be allowed to use these identity reference sheet. I don't expect you guys to have that memorized. And you're also going to be allowed to use your unit circle. These two references are super important for what we're doing on the test. Okay, so let's start on the review. So it's going to start with sum and difference of angles identities, only here's 4 problems. It doesn't tell you which one to use. Do you use sum or do you use difference? So this is where you're going to have to look at your angles and decide which one is best. So say this one here, cosine of 15 degrees. If you look at your unit circle, 15 degrees is not an option, but I know that I can subtract my way to get there. So I'm going to look at my unit circle. So I need to get 15 degrees. So that's too small. It would have been right here. But I can get 45 minus 30, and that'll get me the 15 that I need. So let's do that. So this one, let's instead think of it as cosine of 45 minus 30. Now, we used subtraction and we used cosine. So this is going to be a difference of angles using cosine. So I'm going to go up to my reference sheet. So it was difference and it was cosine. So this right here is the pattern that we need to follow. Okay, so I'm trying to move that identity down so that we can use it. Okay. So there's the identity that we're going to follow. So we would write cosine, and remember A and B just stand for our angles, A, B. Cosine of 45 times cosine of 30 plus sine of 45 times sine of 30. Now, each one of these 4 ratios has an exact value that we can find from the unit circle. So I know for a fact that cosine of 45 is square root of 2 over 2, and so is sine of 45. But I honestly don't know the 30, so let's go up to the unit circle and figure out what that's supposed to be. So sine of 30 and cosine of 30. So here's 30. Cosine is square root of 3 over 2, and sine is 1/2. So square root of 3 over 2 and 1/2. So now we need to multiply. And when you multiply fractions, you just got to do the numerators and the denominators separately. Square root of 6 over 4 plus, and then over here, square root of 2 over 4. And then now let's combine these two. And luckily we already have the same denominator, so we could just combine it into one bigger fraction. And that's going to be our exact value. Okay, so let's try another one. This time it's in radians, but it works the same way. I need 2 numbers that are going to equal 23 pi over 12. So I don't know this right off the bat. I have to go down the list in my head of what I should do. So think of that numerator. What are 2 numbers that add up to 23? So my first instinct is to do 1 plus 22. And remember, these are fractions, so it's 1 over 12 and 22 over 12. The problem is 1 over 12 doesn't simplify, and I need it to, because when you look at your unit circle, none of the radians have 12 at the bottom. So this one is out. Next thing I can try is 2 12s plus 21 12s. So just double check, 2 plus 21, it does equal 23. And in these fractions, can I simplify them? And I think so. This would become 1/6, and this would become 7/4. So this one works. Because I was able to simplify, it'll work. Now we just need to think of it as radians. So this, it would be sine of pi over 6 plus 7 pi over 4. And same thing. So we are adding. That would be a sum, and then it's sine. So when you look at your identities, we need to look at our sum of angles, and then we did sine. So we are going to use this right here. It's sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Okay, so now we'll just fill it in. Sine of pi over 6 times cosine of 7 pi over 4 plus cosine of pi over 6 sine of 7 pi over 4. So let's look at our unit circle now. Sine of pi over 6 is 1/2. And cosine is square root of 3 over 2. So I'm going to write those in first. So this is 1/2. And this is square root of 3 over 2. Okay, so 7 pi over 4, we need cosine and then we need sine. Seven pi over 4 is down here. Cosine is square root of 2 over 2. Sine is negative square root of 2 over 2. So square root 2 over 2, negative square root 2 over 2. So doing what we did before, multiply each of these. So square root of 2 over 4 plus negative square root of 6 over 4. And then we can combine this into a giant fraction. But since it's plus negative, we could just write minus. And there's our exact value for this one. And it's always going to be some combination of those numbers. Okay, our next one, tangent. Tangent does take a little bit more work. That's why they gave us more space for this one. But this time we have negative 285. Anytime you have a negative angle, that's another hint that you're going to have to use subtraction. So looking at the unit circle, trying to get two numbers to subtract and give us negative 285, I think we can do 45 minus 330. Yes. Okay, so I did subtraction. We did tangent. So we need to follow the pattern for difference of angles for tangent. So that'll be this here. Tan A minus tan B, 1 plus. Okay, so let's see if I can remember that. Over 1 plus. Okay, so 45 is our A and 330 is our B. So let's fill this in. Okay, so for this one, we really only need to find two things, tangent of 45 and tangent of 330. So let's look at our unit circle. Here's 45. Tangent is just 1. Here's 330. Tangent is negative square root of 3 over 3. So 1 minus negative square root of 3 over 3 over 1 plus 1 times negative square root of 3 over 3. Okay, so of course we're going to simplify. Right here, minus negative, that's going to turn to a plus sign. Then this 1 stays the same. I already wrote it. 1 times negative square root of 3 is going to just be this. But if I add a negative, that's the same as subtracting. So I'm here. But I don't like having like fractions within fractions. So whatever that denominator is, so in our case it's at 3, you should multiply the whole fraction by 3 over 3. Because 3 over 3 is just 1, but what it's going to do is get rid of those fractions for us. So you need to distribute. The numerator is going to become 3 plus square root 3. The denominator is going to be 3 minus square root 3. Okay, so we're still not done because we're not allowed to have a square root at the bottom. So I'm going to continue this below. So I'm just going to rewrite what we just had. Okay, so we multiply by something called the conjugate. So the bottom, we still use those same two numbers, but since we already had minus, we're going to multiply by plus. Okay, so you do need a FOIL here. 3 times 3 is 9. 3 squared root of 3. Plus another 3 squared root of 3. Plus 3. All over. Then FOIL the bottom. 3 times 3 is 9. 3 times square root of 3. Negative 3 square root of 3. And negative 3. So what's good is that in the numerator, the two terms that have square roots of 3 are going to be gone. So we're going to simplify everything that we have left. Combining like terms, 9 plus 3 is 12. And then I have 6 square root of 3. Then at the bottom, 9 minus 3 is 6. One last thing is that I can treat each one like its own fraction. So 12 divided by 6 and 6 divided by 6. And that gives us 2 plus square root 3. Okay, and then another tangent one. This time it's 7 pi over 12. So same thing. I know that 12, like there is no radian that has 12 at the bottom. So this is my hint that I'm going to change it. It's a positive 7, so I think this time we can add. And I'm just going to go down a list of possibilities. I could do 1/12 plus 6/12, but 1/12 won't simplify, so that won't work. 2 over 12 plus 5 over 12, but 5 over 12 won't simplify, so this won't work. 3/12 plus 4/12. Yes, I think that's going to be the one that works because each one of these will simplify. This is 1/4 and this is 1/3. So I can change this to tangent of pi over 4 plus pi over 3. Okay, so this time it's a sum and it's tangent. So we're going to look at our identities and figure out which one to use. But honestly, it's kind of like this one. It's just that the signs change. So I could tell you right now that the identity is going to say tan A plus tan B over 1 minus tan A times tan B. So let's fill in what we have. So tan of pi over 4 plus tan of pi over 3. Okay, so I need to find those values. What is the tangent of pi over 4 and what is the tangent of pi over 3? So tangent of pi over 4 is 1. Here's pi over 3. It's square root of 3. So 1 and square root of 3. So 1 plus square root 3. 1 minus 1 times square root of 3. Then we would simplify. So that bottom part is just going to be 1 minus square root of 3. Then just like we did before, we need to multiply by its conjugate. So since it has 1 minus, we're going to multiply by 1 plus square root of 3. Let's FOIL this out. 1 times 1, then 1 times square root of 3. And then I went ahead, square root of 3 times 1, square root of 3 times square root of 3. Then same thing to the bottom. 1 plus square root of 3 minus square root of 3 minus 3. In the denominator, those two terms cancel out, which is good. So we get 4 plus square root of 3 over negative 2. And then to simplify, we have to divide by that negative 2. And that gives us negative 2. There should have been a 2 here. Negative 2 minus square root of 3. So normally you want the positive term to be first, but in this case, they're both negative. So there is no positive term. So that is our answer. Okay, so all of that was just sum and difference of angles. We still have a few more to go. So the next type we did was double angle and half angle identities. So again, it doesn't tell you specifically which one to use, but there's tan to theta. That is a double angle identity. So if cosine of theta is 1/3 and 0 is less than theta is less than pi over 2, find tangent of 2 theta. So according to this part, that is quadrant 1, which is a good thing because everything in quadrant 1 is positive. So let's look at the formula for tangent of 2 theta. That way we can see exactly what we need to find. So double angles, they're right there. I need tangent. So I actually need to find tangent of regular theta in order to find tangent of that double angle. Okay, so the way that we do that is that we know that that cosine that they gave us is x over r. Tangent is y over x. So we need to find y. So if we follow the Pythagorean theorem, let's plug in what we have. And solve for y. So this would be 1 plus y squared equals 9. Y squared equals 8. So y would equal square root of 8, which is 2 square root of 2. We're in quadrant 1, so I know everything's positive. So now for tangent, it's y over x. So tangent's going to be, here's y, 2 square root of 2 over 1. So really, it's just 2 square root of 2. Okay, so that's not the answer yet, but we need that value. Okay, the identity for tangent of that double angle was 2 times tangent of the regular angle divided by 1 minus tangent squared theta. So we're going to plug in what we have. The 2 has to be there. That's part of the formula. But tangent theta, we just said, is 2 square root of 2. Then at the bottom, 1 minus 2 square root of 2 squared. So numerator is going to be 4 square root of 2. The bottom, we have 1 minus well, I'm going to work backwards. If the square root of 8 is 2 squared root of 2, so if I were to square it, I would go back to 8. So I know it's going to be 1 minus 8. So that's 4 square root of 2 over negative 7. I don't think anything can simplify. The only thing that's weird is that negative sign. So this is our final answer. Tangent of that double angle is negative 4 square root of 2 over 7. It just looks better when the negative's out front. Okay, next one. If tangent y is negative 6 square root of 2 over 7, and pi over 2 is less than y is less than pi, find sine of 2y. So again, the first thing I like to do is, according to this part, that's going to be quadrant 1. No, I'm sorry, quadrant 2. So if I want to find sine of 2y, I'm going to go look at my double angle identities. Here it is. I need to know regular sine and regular cosine. And they gave me tangent, so I'm going to have to find both of them. Tangent is y over x, so we do need to find r. So let's do 7 squared plus 6 square root of 2 squared is equal to r squared. That would be 49 plus 72. That gives me 121, which is a perfect square, so that's good. R is going to be 11. Okay, so for cosine, it's x over r. So it'd be 7 over 11. And since we're in quadrant 2, that's going to be negative. And then for sine, it's y over r. So 6 square root of 2 over 11. And since we're in quadrant 2, sine is positive. Okay, so now for the actual identity. To find sine of, I was using thetas and they used y. So let me go back to y. You need to do 2 times sine y cosine y. Okay, so that 2 has to be there. Sine is 6 square root of 2 over 11, and cosine is negative 7 over 11. So we're going to multiply all of the numerator and then all of the denominator. So 2 times 6 is 12. 12 times negative 7 would be negative 84 square root of 2. Then at the bottom, 11 times 11 is 121. And then 84 over 121, it doesn't simplify, so it's going to stay like that. Sine of 2y is negative 84 square root of 2 over 121. Okay, so this review is starting to get a little long, so I'm going to go ahead and cut it right here, and then I'll make a second video for the second part of the review.